Hi guys, welcome to my YouTube channel, and in this video we will be discussing about the Nginx architecture in depth, the same way we did for Apache web server in my last lecture. And before moving on with this video, I would request you guys to please subscribe to this channel in case you are not subscribed. That acts for me, it acts as a motivation to come up with more content, right? So let's quickly begin with the Nginx architecture. So in the last video we discussed that Apache web server, the way it works is one thread per connection. So the main process, the child processes, right, that are being created by the main process in Apache web server keeps on listen on a particular port number, let's say which is 80, and then that particular child process spawns a lot of fixed number of threads for as a listener threads, and also a number of threads for your worker threads. So listener threads keeps on listening to your particular port. If there is a new connection, TCP connection comes in, they keeps on listen, picks that request, take it forward to the worker thread, and worker thread fulfill the request, prepare the response, send it back to listener thread, and from there over TCP connection, over HTTP, it sends the response back to your client. So that's how your Apache web server worked, right? In our last lecture we discussed that in depth, so if you want to refer before starting this video, you can go to my videos and refer that video. Alright, so now let's talk about Nginx architecture. Nginx is pretty much faster if you compare it with the Apache web server, because because Apache web server, it doesn't scale well. The problem with is, although you have n number of threads, that's the problem, right? You end up creating multiple threads, n number of threads, and then let's say if you are working on two CPU core CPU, then what happens, only let's say two processes can work parallelly, right? And although there will be threads, number of threads can work within a process, but still you can have only two processes at a time. So there will be a lot of thrashing happens. Thrashing, when I say, let's say, keep on context switching, because CPU has to sometimes give some resources and time to your process 1, and then the process 2, or let's say process 3, or let's say we are talking about in terms of thread 1, thread 2. So it's keep on switching here and there rather than actually executing your request. So that's the concept of thrashing. So what happens is, if processor keeps doing it for a longer time, then your performance all of a sudden degrades, right? So that's the problem of thrashing. And then again, there are a lot of time involved, right? When you talk to, or when you basically work with threads, right, you have to manage the life cycle of thread. So that also takes a lot of time. So those are the problems that are being associated with Apache web server. That's the reason it doesn't scale well, because to handle maximum number of connections per second, you will have to scale vertically your Apache web server by adding much resources into it, but vertically scaling can go only up to a limit. So that's the limitation with Apache web server, and that's the beauty of Nginx architecture, because today Nginx architecture can handle thousands of connections per worker, right? So Nginx architecture scales well, and the way Nginx architecture has been designed, it works perfectly for your reverse proxy. We discussed about the concept of reverse proxy in my last video, where I said that you basically set one system in between, which consumes your incoming request and see, okay, I have to reroute this particular request to this particular web server. So it keep on rerouting here and there. So this reverse proxy have to be a component which can handle maximum number of connections at a time, right? So and that's what I'm saying, because of the fact Nginx can handle maximum number of connections per second. And that's the reason Nginx is a perfect candidate for your reverse proxy. But let's not talk about it. Let's quickly begin with the internal implementation of Nginx architecture. And also, one fact that I want to share with you guys is, whatever information, even as I said right in my last video, whatever information I shared with you, I've taken that information and I studied that information from the official website of Apache. And the same way, this whole information that I'll be talking about, this information I have taken from the book Architecture Open Source Application, where some senior guy from the Nginx has written the implementation around it, right? So that's the source. I will again update the book into my GitHub and share the link. You can always go over it whenever you get time, right? So let's quickly begin with your Nginx architecture. So Nginx architecture also has your master process. So when you start your Nginx, what it does is the master process. When you start Nginx, your master process starts running, and it basically creates 3 different processes: cache loader, cache manager, and your worker process, right? So your cache loader and cache manager are not the major focus area in this video. However, the role of worker process, right, is the main process which we will be talking about and done. So let's quickly begin and understand that what is your cache loader and cache manager. So master thread, you already know, right? When you start your Nginx, it will pick up all the configuration and then it will bind itself to a particular port number, right? And then it also creates 3 different processes. One process is cache loader. So cache loader basically caches some data from your disk. So it basically, cache manager, cache loader manages the cache lifecycle for your Nginx, right? And then cache loader loads it from the disk, and cache manager manages that particular lifecycle. So it periodically keep on looking for disk if there is any data to cache, right? So that's also plays a bigger role to make your Nginx working faster, because you have caching in place, right? Third important thing is your worker process. So worker process is the one that handles all the network communications, network connections. So it will read the connection, take the request. Whenever I say take the request, means read the request. It will write and communicate. Let's say if your service needs to talk to some upstream service, right? And then it will take that particular request to that service. Or let's say your service, request is, as part of your request, you are talking to a database. But let's say you are using Nginx as your reverse proxy, so that means you will have upstream services, right? That's how reverse proxy works. You might have, let's say, some X service and some Y service. So it will take that particular request to your X service, will get the data from there, and then send it back to the client over the TCP connection, right? So these are the 3 main processes involved. One is your cache loader, second is your cache manager, and third one is your worker processor, right? So let's move on and try to understand the Nginx worker process in depth. So the fundamental thumb rule, right, the fundamental principle of your Nginx is the non-blocking nature of it. That's how it makes it faster, right? Even if you look at Spring, we have the traditional Spring model where every request converts to one thread, right? So each thread is taken by one thread, completed, and send the response back. Then you have the Spring reactive, because as part of the basic Spring, what you had or also as part of the Apache web server, what you had is you have the blocking calls. What it means is, so let's go back and then let's understand, right, that what does it mean by when I say the blocking nature. So the way it was working, so let's say this is your client, right, and then this is your, let's say, worker thread, right, and let's say this is some, let's say, disk, or disk, and let's say this is some external service. So the way the blocking nature of thread will work is, this will send this request here, right, over a TCP connection. Then this worker thread will pick that request, and then let's say as part of the request, it needs to talk to your disk. So it will go to the disk, right, and then perform some kind of IO operation, right? And then till the time that IO operation gets completed, this particular thread T1, it will keep on waiting, right? So when I say waiting, that means it's in the blocked state. And then again, once your IO operation is completed, this thread will get the response from here, and then let's say it will send the response back. So you see, it's not it's not unblocking nature, it's kind of the way it is working, it's blocking nature. So you are sending response and then that particular thread is on hold till the time that IO operation gets completed. So that's the blocking nature of your thread, and that's the problem with the traditional Apache web server and also the basic traditional Spring web server, because you have blocking things in place. You have to wait till the time your operation gets completed. Operation could be anything, it could be IO operation, it could be you may be talking to some, it could be network call, it could be database call. Although database call will also be a network call, but the point is your system, your thread needs to be on hold till the time your operation gets completed, right? So now let's go back and then understand the non-blocking nature of your worker processor. So that's the beauty. The first, let's go through all the points. First is non-blocking nature. So I already said you understood what is blocking. Let's also opposite, we will discuss what is unblocking, right, using drawing. First, let's go over all the points. It's event driven, right? It wait for some event to happen, and then based on that event, that threads or that particular process get itself initiated, get itself started, right? So the wait for events on the listen sockets. Socket is nothing. For example, let's say in your operating system you have sockets where you are listening on those sockets for a network call, for a network incoming connection, right? So wait for events on the listen sockets. Events are initiated by new incoming connection. So let's say there is a new TCP connection comes in, and then there is an event E happens, and then based on the event E happens, this worker processor understand, okay, there is a new event that I have to take it forward and get it processed, right? It asynchronous nature. We will understand what is asynchronous nature, but anyways, in my one of the video I have explained the asynchronous. So, and then one process per core. So, and again, understand, it's not one process per incoming request, it's one process per core. That's the reason it is scaled well, right? I'll tell you. Let's go over one by one each point. So okay, so in this drawing I told you that this whole thing, the way it is going, right, it is going, request is moving to your worker thread, and then from worker thread, this worker thread took this request and send it to your disk, and till the time input output operation, this IO operation gets completed, it will be on hold and will come back with the response, right? So this way, this whole nature is first of all blocking nature. I already told you. Also, this is known as synchronous call. Why synchronous? Everything is in sync. Everything is sync. You see, there is nothing is getting break in between, right? So everything is in waiting state till the time things are completed. So this is also synchronous nature. We also call it synchronous call, and also you can also call it a blocking nature, right? Blocking nature of thread. So this is one thing. Second thing is one worker processor per core. So let's say, so the reason Nginx scales well today is let's say you have your 3-core CPU. Let's say, so let's say you have 3-core CPU. So this is core 1, core 2, and core 3. Now the default way Nginx comes with is it creates the number of process equal to the number of cores available, right? So you could say number of process equal to number of cores. So that's where the half of the problem gets solved, right? Why? Because you will have one process working here, you call it P1, and you will have one process working here, P2, you will have one process working here, P3, right? Now all these processes, you see, all these process, now because you have number of process equal to number of cores, so these 3 processes can work together in parallel, right? 3 processes can work in parallel. So when I say these 3 processes can work in parallel, then that also means that none of the process has to wait for anything, right? So that means your CPU resources, and if you have your CPU here, this CPU can dedicate it its time, because it's CPU, right? It's part of all CPU. Then your CPU can dedicate its time together at the same time for this guy, also for this guy, and also for this guy, right? And this is all parallel. That also means that CPU doesn't has to switch between P1, P2, and P3. So as we have in the Apache web server, it basically has n number of child process, and in between we have n number of threads. So CPU has to switch between sometimes thread 1, thread 2, thread 3, thread 4, then again thread 1, thread 2, thread 3, thread 4. This whole process of switching between the inter processes is known as, I use the term thread, assume it's thread or process, it doesn't matter, because a thread is a lightweight process, so it is inside a process. So let's use the analogy of process, it will make things easier. So CPU has to keep on switching between multiple processes, right? So this process is known as context switching. Now the context switching will itself also need some kind of CPU time and execution. So this process will makes the performance tends to degrade more, right? That's the reason Apache web server doesn't scale well. I already told you right in the beginning of session, and that's the reason, because of the fact CPU can execute these process parallelly, you can scale your application well. All you need is just to increase the number of cores, you will have the stronger machine, right? And CPU doesn't has to do the context switching. And also if you have more number of processes, the process also comes with its life cycle, thread also comes with its life cycle, all those things have to be managed internally, right, by CPU. So CPU also basically loses its time in all those processes, and hence those things is not Apache web servers like Apache are not in situation to handle multiple connection at a time. Now because of this fact, right, your Nginx scales well and can handle multiple connections. But we still haven't discussed that why P1 is faster, although we did, right? But we did not discuss how it works in Nginx. We did, it's of blocking, it's of not blocking in nature. So because in Apache web server it's a blocking call, in Nginx it's not, everything is unblocking, right? It's non-blocking. So it doesn't get blocked until the time any IO operation gets completed. So what it does, it take your request, send it to the disk, and then till the time your and then comes back. It doesn't wait for an IO operation to get completed. So let's go back and understand that non-blocking nature of your or assuming in the thread, right? The thread is, let's say thread is executing a request. So the way it will work, let's say you have this process and then you have this thread, right? And then this is your client, right? So client sends a request here, and then you have a disk kind of here, right? So this guy will pick this request, and then this again is coming on a TCP request. So it will pick this request, and then as part of your request it needs to again do an IO operation. So it will take that request, send it to, and send that particular, invoke the disk, right, input operation, and then right after then and there it will come back right here. So it will invoke this and it will come back. So this is 1, this is 2, and this is 3. Now, and so it is free, right? Because it has taken the request and send it to your disk. The whatever input output operation needs to be done, it's invoke that and come back. Now disk, whenever your disk, let's say, which is as part of operating system, will call back to your process saying, hey, I am complete. So this process will pick this request and then send it back to your client, right? So this is all non-blocking nature of your thread or process, right? Because you see, it's not waiting for input output operation to get completed. What it's doing is taken the request, invoked that input output operation, and then right then and there it came back. And then the moment this operation got completed, your operating system did a callback to your process and then said, hey, this process is completed. Then your right then and there, this particular process picked up that callback response and then process it and send it back to your client. So that's the non-blocking nature, right? You also see, and people also call it that asynchronous call, right? So, but there is one important thing to understand, this callback, right? So this whole ecosystem of Nginx, it's not only Nginx, it's an ecosystem of events. It's the ecosystem of your non-blocking implementation of worker process, and then also the asynchronous implementation, or also the callbacks, right? All this, the ecosystem of all those things makes your Nginx faster. All right. So callback is nothing. Callback is a simple process. Let's say I go out from my house and I tell my wife that I'm giving you these 20 rupees, right? And whenever this person X comes in to pick this 20 rupees, you basically call me back on my number and tell me that he has picked up 20 rupees successfully. So this is callback process. I have given her 20 rupees and I will not wait for my wife to call me back, right? By just standing or sitting there in my house, I will go out and do my work. So my energy and bandwidth efficiently is being used in some other work, and at the same time, after some time X, when the person comes in, my wife will call me back and say, hey, he has successfully picked the 20 rupees, right? So that's the callback function from my wife to myself. So that's the callback. All right, so now let's move on to our slide. So we discussed all these concepts. Now let's quickly discuss this as well. The issues with one thread per request model is it doesn't work as Apache Web Server, creating one thread per connection, right? So as I already told you, Apache Web Server, it works as one thread per connection, but here it is not the case. And then this above model doesn't scale well for hundred thousands of connection, spawning new threads, process preparation of new runtime environment, including allocated heap and stack, also creation of new execution context and thrashing. So concept of thrashing we already discussed. If CPU invests a lot of time in context switching comparatively to actually executing the processes, that means your system will degrade, because CPU is not actually executing the processes but actually investing its time in context switching. So that's the problem of thrashing. Thrashing always in the concept of operating system, it always makes your system perform very bad. Also, as I said, because for per connection, let's say you have n number of connection, you will end up creating n number of threads, and that is also a fact that you won't create n number of threads, but you will have n number of thread pool, right? And from the thread pool you will keep on using your threads. If one of your thread is available. But problem with thread pool, because you won't have your thread pool maybe not equal to number of cores available, you might end up having multiple threads in your thread pool. So those will also create the problem, because every thread or process will come up with their own runtime, and every time you execute process, your CPU execute a thread or process, it has to allocate some kind of heap or stack for its processing, right? So all those technical things happens behind the scenes, right, in the operating system ground level. So that consumes a lot of time and it does not make the system well, and hence you don't have an Nginx. So in Nginx you have this kind of architecture, right? So you see you have this master thread, and then these are the worker thread, right? And then, so as I said, the worker process, I would say, let's use the analogy of worker process, and these worker process are listening on your HTTP ports, right? And it is listening for the events from operating system for a connection to be made, right? And then it listens, and by listening it take up that request, and then maybe it talks to the backend, and backend could be upstream other web services. It also, if there is anything to be picked up from your disk, if it also looks in the cache, if your cache loader or cache manager is managing those values in your cache, right? It also does all the input output operations. And then there is another important term. You see there are three important terms. I already told you event driven, asynchronous and non-blocking. We already discussed. Event driven means it is it waits for an event, right? If let's say a connection gets created, operating system emits an event E1, then it's listening if there is an event E1. So if event E1 comes in, your worker threads kicks in and it starts processing, right? Now it also uses the concept of multiplexing. So understand, multiplexing is a basic usual concept in telecommunication. So I'll quickly tell you. So that also makes your processing faster, right? In Nginx, I'll tell you how your multiplexing works. Is, let's say, even in my video of HTTP, how HTTP works, if you go, I have there explain you the concept of multiplexing. So that's how, if you see, right, you are using, as part of REST, you are using HTTP1, but we also have HTTP2, which is in the binary format, which is actually much faster than the HTTP1. Reason behind multiplexing, right? Here also you have multiplexing too. So multiplexing in telecommunication is a technique to consolidate multiple things into one single stream, right? For example, let's say there are multiple requests coming in, right? These are requests. So rather than, and then let's say there is one process, rather than you creating multiple process for each request, what you could do, or let's say this process, rather than taking all the requests one by one, right, to your backend or wherever you want to take the request, what you're doing is you are picking up all the requests and sending it as one call, right? So if you see here, you will end up losing a lot of resources, but here you not end up losing a lot of resources. So again, you can scale well, which will basically makes you to handle multiple concurrent connections at a time per second, right? Now, all right, guys. So we discussed this, right? The whole architecture. So I already, from the beginning of this lecture, I have been telling you that it has the worker process, etc., this whole ecosystem. And then in the last slide, if you see, I have explained the same thing, right? Where a HTTP connection comes in and this worker process picks that request and send it to your your disk. Let's say if there is a input output operation, right, and then in there it's not blocked, it comes back, and then whenever this operation is completed, your operating system comes with a callback response. This process will pick up that particular response, prepare the response and send it back to your client. So it's the non-blocking nature of your. So I've been telling you, right, from the since beginning, right, this non-blocking nature of your Nginx. So this whole properties of event-driven, asynchronous, and then non-blocking nature, callbacks, all those things makes your Nginx works pretty much faster in comparison to your Apache web server, right? So that was about the Nginx architecture, and in the last words, I would simply tell you that Nginx is a better candidate for reverse proxy. In the beginning also I told you, because of the fact it can scale well, so it can handle multiple number of connections per second, and hence it is a good suitable candidate for a reverse proxy, because as part of reverse proxy you have to handle a lot of connections concurrently, right? So Nginx, you can always go ahead and use Nginx as a reverse proxy. Alright, so in this video we discussed the architecture of Nginx. We also discussed the different type of Nginx processes. We also discussed about the Apache web server working versus the Nginx working. We also discussed about this architecture implementation, and we discussed about the non-blocking nature of your worker process in Nginx. Alright guys, so in this video we have discussed so far these things, and then next video will come up with another topic in system design. And so far I hope you have learned well. If there is any another topic you want me to come with, please mention that in the comment, and I'll try to prepare a video. Thank you guys.